Welcome to Control Engineering lecture series. I, Professor Ritesh Dolakia, is going to explain you one example of Bode plot in which we are deal with to calculate value of k for unity feedback control system having open loop transfer function GS HS is equals to k divided by s plus 2 s plus 4, and we are deal with to find value of k for gain margin is equals to 20 dB, and we are deal with to find value of k for phase margin is equals to 60 degree. So here first we will be plotting Bode plot of this given system, and based on Bode plot we will identify value of k for gain margin is equals to 20 dB and value of k for phase margin is equals to 60 degree. So in plotting of Bode plot, first step is to write standard form of given transfer function. So to write standard form, all we need to do is we just need to write this corner frequencies in form of 1 plus s divided by something. So here you see in numerator there is nothing in terms of corner frequency, but in denominator s plus 2 and s plus 4 is there. So we need to take 2 and 4 common from this and we can have standard form. So you see how I am writing it. I am taking 2 and 4 common from denominator, so k by 8 divided by s into 1 plus s by 2 1 plus s by 4. See, this is how I am writing standard form, right? And let us consider here our constant is k dash. So constant, that is k dash, as k is already used, so k dash is equals to k divided by 8, right? Now second step is to find slope of first line. So slope of first line, that is based on poles or zeros at origin. Here you can observe there is one pole at origin, means slope of first line, that is minus 20 dB per decade, right? Now third step, that is to identify gain of first line at omega is equals to 1 radian per second. So gain of first line, that is at omega is equals to 1 radian per second, that we can identify as per 20 log of constant. So here you see constant is k dash, so I am saying this is k dash and that is 20 log of k by 8, right? Now here if I consider k dash is equals to 1, right? In that case I can say 20 log of 1, that is 0. So gain of first line, that is 0 dB, as we have considered k dash is equals to 1 over here, right? And by considering k dash is equals to 1, first we will be plotting Bode plot. Consider this, and after that based on Bode plot we will see how to identify value of k for this gain margin and this phase margin, right? Now let us see fourth step, and in fourth step we will be writing all corner frequency in ascending order and we will find a slope of each line. So if you observe our transfer function, then from the transfer function we can say first corner frequency, that is there at origin, so 0. After that we have second corner frequency, that is there at omega is equals to 2, and after that third corner frequency, that is happening at omega is equals to 4. So we have 3 corner frequencies, so I need to write all corner frequencies in ascending order. Now next is we need to write pole or zero at each corner frequency, and here with all corner frequencies there are poles, So here we need to mention pole with each corner frequency. With pole and 0, we have a slope with each line. So if we have one pole over here at origin, we have slope which is minus 20 dB per decade. Then another pole is there at 2, so another slope is minus 20 dB per decade. And another pole is there at 4, so again slope is minus 20 dB per decade. And here we will be finding resultant slope and first line slope, that is minus 20 dB per decade. Let me keep as it is. Now next line slope, that is previous slope plus current slope, so minus 20 minus 20 minus 40 dB per decade. Next line slope, that is previous slope plus current slope, so previous is minus 40 minus 20 minus 60 dB per decade. See, this is how we can identify slope of each line. So first line slope is minus 20 dB per decade, second line slope is minus 40 dB per decade, and third line slope, that is minus 60 dB per decade. Now fourth step, that is to write phase equation and make a table of phase with respect to frequency. So if you observe our standard form, in that if you place S is equals to j omega, then we can have a phase equation, and in that if you observe at origin there is one pole, so for that phase is minus 90 degree, and then you see 1 plus S by 2 means 1 plus j omega by 2 is there, and there we have a pole, so minus tan inverse omega by 2, that is a phase, and another corner frequency, that is 1 plus j omega by 4 means there is a pole, so minus tan inverse omega by 4, that is the phase which we need to write. Now here we will be making a table of phase with respect to frequency. So you see, here we have frequency and here we have a phase, and we are deal with to have a table of it. So let us consider first omega is equals to 0.1, and I am just finding phase. You see, that is minus 94. Now in this same equation I am just placing omega is equals to 0.5 and angle is minus 111. Now next I am just placing omega is equals to 1. So you see 001 that I need to write, and phase is minus 130. Now few more values that I need to have for omega to have proper plotting of phase with respect to frequency. So let us say we have omega is equals to 2. So for omega is equals to 2, phase is minus 161. Then for omega is equals to 5, phase is minus 209. Then omega is equals to 10, phase is minus 236, and now I am taking omega is equals to 100, phase is minus 266. So this is how we have a phase table with respect to frequency. Now I will plot Bode plot for this given data which we have calculated right now. So see, this is semi-log graph paper which we have, and here we have frequency on this axis. Let us say this is omega. Now here you see first I am considering frequency 0.1 over here, and on this semi-log graph paper you see this is 1, 2, 3, 4 like this. So if this is 0.1, this has to be 0.2, 0.3, 0.4, likewise here it will be 1, then 1, 2, 3, 4, likewise here it will be 10, then 10, 20, 30, 40, likewise here it will be 100, then 100, 200, 300, 400, likewise it will be 1000. See, this is our semi-log graph paper that we have, right? And first we will be having a plot of gain, right? So here all I am considering is this is our gain plot where 0 dB that I am considering over here, and here there is 20 dB, and here there is 40 dB, and here there is minus 20 dB, minus 40 dB, and minus 60 dB. That is how it is there with us, right? And first we need to have this 0 dB line extended over this side, right? As gain crossover frequency that is happening at 0 dB, I am just extending 0 dB line like this. Now let us try to understand what will be our first line as per the calculation. So as per the calculation, if you see, our first line is having slope minus 20 dB per decade, and gain is 0 dB at omega is equals to 1 radian per second. So omega is equals to 1 radian per second, that is this. So that point is over here, and slope is minus 20 dB per decade. So you see 1 to 1 over here that is happening. So this is 1 decade, and you see 20 dB that is this, right? So if I stretch a line, right, so this is our first line, and I can say this first line is 1 by S, right? This first line, that is 1 by S, and that is having slope minus 20 dB per decade. Now if you see the table, in that second corner frequency, that is omega is equals to 2, right? So omega is equals to 2, that is happening, you see this is 1 and this is 2, so omega is equals to 2, that is happening over here. So make a point, and that is having a slope minus 40 dB per decade, right? So my 2 to 2 that is happening over here, and here all you need to do is you just need to see a scale. You see here to here there is 1 inch, right? Here to here there is 1 inch, and 1 inch is equals to 40 dB, you see, right? So here 1 to 1, that is there is 1 decade, and 1 decade to 1 inch there is 40 dB. And if I have a line from this, then this line is having a slope which is minus 40 dB per decade, and this is our 1 divided by S plus 2 line, and that is having slope minus 40 dB per decade. Now if you see our next corner frequency, then that is happening at omega is equals to 4. So you see this is 2, this is 4, right? So that is happening somewhere over here. So make a bubble. Now 4 to 4 somewhere over here, and 60 dB, so that I need to say, so here to here 20, here to here 40, here to here 60, right? So all I need to do is I need to stretch a line from this, and this is our third line, that is 1 by S plus 4 line, that is having a slope minus 60 dB per decade. So this is how we can have a gain plotting, right? And in this, let me tell you, see, actual gain plot, that is corner frequency to corner frequency only. So that is this. These are just extension, right? You see, so this is our actual gain plot that one should know, right? Now let us have a phase plotting. So for phase plotting, all I'll be doing is I'll be considering minus 180 degree over here, here minus 150, here minus 120, here there is minus 90, here there is minus 210, minus 240 and minus 270. This is how it is there. And see, minus 180 degree, that should be our reference. So for phase crossover frequency, I need to have this. So I am stretching a line from minus 180 degree, right? Now if you see the table which we have calculated, so as per the table we need to place values. So at 0.1 radian per second, point is there at 94, so that is somewhere over here. 0.1, that is this, you see. Then at 0.5 angle is 111, so at 0.5 means 0.2, 0.3, 0.5 over here, 111, that is somewhere over here. Then next point that we have seen, that was at 1 and phase was minus 130, so minus 130, see this is 1 frequency and minus 130, that is somewhere over here. And then at 2 it is 161, so at 2 it is 161, somewhere over here. Now from these points, all I can do is I can just stretch a line from this. If you want higher precision, then you can take more points, right, to have higher precision. Now we have this graph, which is what? Bode plot graph. Now from this graph, right now, see, if you consider k dash is equals to 1, then this is what our gain crossover frequency, that is 1 radian per second, and this is our phase crossover frequency, that is, you see, that is very nearer to 3 but little lower than that, so 2.8, right. And if you stretch a vertical line like this, then this will be our phase margin, and if you stretch vertical line from this, this will be our gain margin. And if you see phase margin, then that is, you see, 30 plus 20 approximately, so I can say that is 50 degree. And if you see gain margin, so for 5 boxes it is 20, so for 3 boxes it is 12, so I am saying gain margin is 12 dB. And this is what we have for which values? This is what we have for k dash is equals to 1, right. And if you see k dash, that is k by 8, right, and that is what we have kept, k dash is equals to 1 to have this plot, right. Now our question is find k for gain margin is equals to 20 dB, right. Find that gain margin, find the value of k for gain margin is equals to 20 dB. So how to calculate this? So you see, to calculate that, all we need to do is 20 log of k1, that should be equals to gain margin minus 20. See, 20 that is required. So actual gain margin minus 20 that we need to do. And here 20 log of K1. You see gain margin over here we have calculated, that is 12. So I am saying this is 12 minus 20. So I can say, see, 20 log of K1 that is minus 8. So log of K1 that is minus 0.4. So we can have K1 and K1 is 0.39. And if you see K1 is K by 8. Sorry, I have written K1, it is actually K dash, right? So K dash is K by 8. So multiply by 8 that we need to do to have value of K. So 3.18. This is our first answer for K 3.18 if gain margin is 20 dB. Now second question, that is what? Find a K for phase margin that is 60 degree, right? So first of all we need to see at what location it is 60 degree, right? So I am just observing it is happening somewhere over here, right? 60 degree. You see 180 to 120. So this is what? 60 degree phase margin, right? Phase margin is equals to 60 degree. If you stretch upward line, then that is happening like this. So here all we need to do is we need to see how much value is there with this, right? So that is approximately, one can say it is 4, right? Gain margin that is approximately 4. Now here there are few points that one should know. See, gain margin that is negative over here and positive over here, and phase margin that is positive over here and negative over here, right? So this is our gain margin, that is minus 4, that one can say over here, right? So what I'll be doing is, for a calculation of K, I am considering that at phase margin 60 degree gain margin is minus 4. So I just need to place that over here. So 20 log of K dash that is equals to minus 4. So log of K dash that is equals to minus 0.2, right? And if you calculate this K dash, then it will be K dash is equals to minus 0.63, and K dash is K by 8. So multiply by 8, that will make it to K. So that is 5.04. So now we have a value of K with phase margin 60 degree. So this is how we can use Bode plot to identify value of constant for given gain margin and phase margin. I hope you have understood this video. Thank you so much for watching this video. Please do give your valuable suggestions. The reason is your suggestions matters to me, and based on that in future I'll be making videos which will solve your queries. So please do give your valuable suggestions. Thank you so much.